In this video, we're going to be taking a look at the Tutrees SP5 Core XY 3D printer. Now lately, I've been getting a lot of proposals to test various machines, and I'll be honest, I almost passed up on this one. I took a second look at it and I noticed that the machine construction seemed really solid. It's got linear rails on all three axes, and it comes at a very reasonable price point. So I decided to give it a go, test it out, and I'm glad I did. I'll give you my detailed thoughts at the end of the video, but keep watching because through the video, I've got a couple upgrades here for this machine. One of them being an auto bed leveling sensor, which I'll show you how to set up, a PEI coated flex plate, and various other 3D printed accessories, which I made all available for free on my printables page, link in the video description down below. Thanks to Tutrees for sending me this printer, so without wasting any more time, let's get started. So first, let's take a look at the unboxing and see what's included with the Tutrees SP5. And in the top layer of the packaging, you'll find your USB cable, a sample roll of filament, a bunch of tools and accessories in this bag here, some brackets, mounting brackets, feet, the bed leveling screws, and various other small components, a hardware bag, and in this pocket here, you'll find the extruder. Packed away tightly in this piece of foam, you'll find the mounting brackets for the print bed, and on the sides, you'll find extrusions, some of them with linear rails already mounted. Next, I'll pull out the top frame of the printer, and this has the entire Core XY mechanism already pre-assembled. Under that, we have the heated bed. In the bottom piece of packaging, you'll find many more aluminum extrusions, the Z-axis rods, and under that, you'll find the base of the printer, which houses all of the electronics, and the hot end is already attached. We can prepare for the assembly of the printer by placing the base face down on the table, but before we get into the assembly, we'll take a quick look inside of the printer base to see some of the electronics hidden inside. What's really convenient about the SP5 is that Tutrees put these access panels on the top of the base, and you can see the machine is running a MakerBase Robin Nano mainboard with replaceable drivers. Mine came with the TMC 2209 drivers. At the rear of the base, we have another access panel where the main wiring harness enters into the base, and this makes for easy access to the wiring harness and being able to fish new wires in or out of the enclosure. You can see here that I put an extra layer of wire wrap around the harness just to keep it protected. Opening the enclosure at the bottom, you can see that the two Z stepper motors are actually belted together under the printer base. I was happy to see that so that the two Z stepper motors will never become out of sync. You can also see this fan here blowing across the side of the mainboard, and this is providing cooling to the drivers. With that out of the way, we can now take a look at getting this thing assembled. So first we'll start with the printer feet. For this, we have to flip the base upside down, but I don't want to rest the weight on top of those Z-axis couplers. So we're going to use a couple pieces of the extrusion that are included in the kit, and we'll rest the frame on top of the extrusion while we screw in the feet. The feet and the hardware come in the same bag, so it's pretty straightforward. There's 4 feet, screw them into the bottom of the base. Now we can grab 4 of the 40/20 profiles, and you'll see that one side is completely closed, and those are going to go on the outside of the printer. The sides with the slots will go on the inside of the printer, but take a quick look at some of these as they do have notches that have been machined into them. The instruction manual isn't the greatest, but it will show these notches, and it shows you to put them towards the outside of the machine, because later you'll find that those notches provide clearance for screws in that T reinforcement frame. With the 40/20 profiles inserted into the base, we can take these M5x16 button head cap screws and start threading them into the sides. There will be 2 per extrusion, and at this point, do not completely tighten them just yet. Flip the printer on its side and you'll have a bag of M5x10 screws, and those will go into the bottom of the extrusions. And again, there'll be 2 of those per extrusion. Next, we can grab the profiles that already have the linear rails installed on them. You'll see that the rails are not centered on the extrusion, and there's a space on the end, which will provide you with enough clearance to be able to insert those extrusions into the base. These will also get attached with 2 M5x10 screws, and again, do not completely tighten these at this point. Repeat the same process for the other side, and just make sure that you have the flat sides of the extrusion facing outwards. Next, you'll find some 20/20 profiles. These are labeled left and right, and so if you're looking at the front of the printer, the left extrusion will go on the left-hand side. As with all of the other extrusions, the flat side will face outwards, and then we're going to grab the M5x30 socket head cap screws and screw those in through the top of those extrusions into the upright extrusions that have the linear rails on. Now we can take our pre-assembled Core XY frame and put it on top of the printer, but I'm putting it on backwards here. The motors that I'm pointing to should actually go at the front of the printer. So flip it around, don't do it like I did. M5x16 button head screws go in the side and M5x10s go on the top. In the kit, there are 4 reinforcement gussets with M4 screws and these T-nuts. And you can pre-assemble them like this, leave some space between the gussets and the T-nuts, and you should be able to wiggle them into the frame. When you tighten the screws, the T-nuts will rotate and lock themselves into the extrusion slots. There are 4 gussets in total, so you'll get 2 per side of the printer. With all of the frame members now in place, we can go around the entire machine and tighten up all of those screws. Then we can grab our print bed support brackets. You'll notice that there are 4 holes on them, and those 4 holes will line up with the 4 threaded holes on the Z-axis carriages. M3x6 screws will hold them in place, but don't tighten those down just yet either. You'll want to drop your threaded rods into the couplers through the lead screw nuts inside of those brackets. You may need to loosen the grub screws to get the rods fully seated, and once they are seated, you can tighten them back up. Now, in an attempt to get these things squared up, I'm using these metal bars here to hold the print bed support brackets before tightening those screws down. And if you don't have metal brackets like I do, you could use anything of equal length, and that includes something as simple as drinking cups. Next, let's grab the Z-axis idler bearings inside of these brackets. You'll find that one of them has the Z-axis limit switch and the other one does not. The one with the limit switch will go on the right-hand side of the machine, and the one without will go on the left-hand side. Pre-assemble the bracket with the included T-nuts and screws, and those T-nuts will go into the slot of the horizontal frame member as seen here. You'll find that the bracket is slotted, so it can move up and down, but it can also move side to side, so make sure that it is square and that you're not twisting your Z-axis rod out of alignment. When you're satisfied with how square the Z-axis rods are, you can tighten down those screws holding the print bed bracket to the Z-axis carriages. Now we can grab the aluminum heated bed platform and we can install the adhesive insulation on the bottom. Don't skip out on this because this should make your bed heat up faster and potentially keep a more uniform temperature across that entire build surface. In your kit, you'll also find a baggie with adjustment knobs as well as these blue springs. The 4 springs sit on top of the holes on the print bed brackets, and within those bags you'll also find these flathead screws. The screws will go through the aluminum bed, through the springs, and down through the support brackets. Then at the bottom we can thread on our adjustment knobs. Turn the knobs to provide tension on the springs, but make incremental adjustments at each corner. Don't do one corner all at once. I'm using these metal bars here again to try and get all 4 corners at about the same distance, and you don't want to do one corner all at once because you may introduce some bending into this plate. By slowly tightening each corner a little at a time, you're less likely to bend this plate. Now, despite taking my own advice, I do have a little bit of a high center on my plate, so we'll see how that affects our prints later on. Up at the top of the machine, we're going to unthread the 3 screws on the print head carriage. Then we can attach our hot end and we can reuse those 3 screws to firmly fix it in place. There are some rectangular holes up at the top where you can attach yourself a zip tie to hold the harness in place, and you'll also find some small threaded screws up there to hold the X-axis limit switch in place. The extruder is next, and it comes with its own small baggie of hardware. It's going to be attached at the rear left-hand side of the frame, but before we do that, we can install the tensioning knob. Place the washer on top of the tensioning arm, take the thumb screw and a spring, and then just simply thread that through the washer, through the hole in the arm, and into the extruder. Then we can grab 2 of the M4 screws and the included T-nuts, pre-assemble them onto the extruder bracket, leave enough space for them to slip inside of the slots on the frame members, wiggle them into the frame and tighten them down. Next, we can grab the white PTFE tube and insert it through the hole in top of the extruder carriage and into the hot end. Make sure you press it all the way down into the hot end so that it's fully seated. Insert the PTFE Bowden tube into your extruder and then take the white P-clamp and wrap it around your hot end wiring harness. There's a set of threaded holes at the back of the frame. Use the M4x8 button head cap screw to hold the P-clamp in place. Beneath the extruder, you can attach the filament spool holder, and the top of the spool holder is round, so that's how you know which side is up. We're finally ready to make some electrical connections, and the first is this large yellow connector, which is the power for the heated bed, and beside that there are two small black plugs, and that's for the heated bed thermistor. Now I did notice on my heated bed that the wire going into the strain relief was rather loose. I unscrewed the strain relief cover and I found that the wire jacket was cut a bit short. That cover should be clamping down on the wire jacket and not the individual conductors inside. I cut a slit in a piece of heat shrink tubing and wrapped it around those wires for some extra protection, then put the cover back on and secured that heat shrink tubing in place with some electrical tape. The Y-axis limit switch wire runs up the rear left side of the frame. You can insert it into the T-slot framing and hold it in place with this wire cover. You'll find the mating connector up at the top, and all of these connectors are keyed and labeled, so it's pretty hard to mess that up. I'm going to zip tie this connector around the main wiring harness to keep it away from the Core XY belts. After that, we can plug in the extruder motor, and there's another connector right beside that, and that's for the filament runout detection sensor. Oddly, this sensor does not come with a bracket to hold it in place, but I have a solution for that and I'll show you guys that a little bit later. Then we can plug in our X and Y motors. Each of these have their own respective plugs that are very clearly labeled and color coded. The blue one is Y, the red one is X, and again you can hide those wires inside of the channels using the wire covers. Similarly, the Z-axis limit switch can get plugged in and you can hide those wires as well. Taking a look at the glass print bed, the bottom has an adhesive layer. I would advise on not permanently adhering your glass plate to the aluminum heated bed. I plan on upgrading to a PEI flex plate, so for now I'm just going to use some binder clips to hold it in place. Before we start printing, we have a few more things to set up. So we can first power on the printer, and then we can head into tools, and then we can hit the preheat button. Tapping on the icon that says extrusion will switch it over to the heated bed, and then we can increase the heated bed set temperature to 60 degrees. Then we can head back into the menu, and we're going to want to home all of our axes. Remember that your Z-axis limit switch is on that adjustable bracket, so if the print bed is crashing into the nozzle, you may need to adjust it downwards. If your limit switch position is okay, we can head into the leveling menu and hit 0.5. This will park the print head in the middle of the bed, and then you can use the knobs at all four corners to adjust the bed up towards the nozzle. Just like when we mounted the print bed, you're going to want to make small adjustments at each corner a little at a time until the print bed is up close enough to the nozzle that there's a slight amount of drag between the nozzle and the print bed when you put a piece of paper between them. On the touchscreen, we can now use points 1 through 4, and that's going to position the print head at all four corners of the print bed. And you can go through the same process with that piece of paper until you find that perfect distance between the nozzle and the print bed at all four corners. Once you're finished at all four corners, you can head back to 0.5, which is the center, and just double check. One other thing that I found that I needed to adjust was the machine size in the machine settings. Essentially, these are the soft limits or the travel limits, and I'm going to change the X-axis maximum stroke and the Y-axis maximum stroke to 300, and in the Z-axis I'm going to change it to 340. I found it a bit strange I had to do this, but maybe you won't have to. Now I'll head back into the preheat menu and switch over to the nozzle temperature, and we'll preheat the nozzle to 210 degrees Celsius. I'm going to load in some gray PLA filament, and first it will get inserted through the filament runout detection sensor. Make sure that the arrow is pointing up towards the extruder. Then I can release the tension on the extruder using that lever, and I can push the filament through the extruder into the Bowden tube and manually feed it all the way to the nozzle. When the filament is pushed all the way to the hot end, you can go into the filament menu, click the load icon, and then the extruder motor will take over and start pushing filament through the nozzle. Now we have the nozzle primed and we're ready to print something. Setting up the slicer for the SP5 is a little outside of the scope of this video, but if you guys are looking for a Prusa slicer profile, head on over to my website. I'll put a link in the video description down below. You'll be able to download it there for free. The first object I'm printing is this fairly common calibration cube. As this was my very first print and I was still developing that slicer profile that I just talked about, I wasn't expecting perfect results. I kept the speeds and accelerations fairly conservative because I just wanted to first successfully lay down a few layers of plastic. My initial educated guesses on all of these settings turned out to be not bad, and the only thing that I really had to adjust first off here was the retraction settings. The walls on the cube looked very uniform. The corners of the cube could be a little bit sharper, but they weren't too round either, and it looked on the top layer that there was a little bit of over extrusion, but I think the real problem here was that I was printing too close to the print bed in the first layers. I also noticed some blobs on the print, and again, this goes back to the retraction settings. This machine has a very long Bowden tube, so I increased the retraction values for the next print, and I printed a bunch of retraction towers. There were quite a few messy prints, like you'll see here in a second, during this trial and error process, but I ended up finding that a 6mm retraction setting was best, and that's at a retraction speed of 50mm per second. If you guys remember during the assembly process, I had also mentioned that the middle of my print bed was kind of humped in the center. The high center of my print bed makes my nozzle too close to the first layer, and then all subsequent layers are dragging material around. In an attempt to fix this, I then tried to print a first layer calibration test. As the print was going on, I was making live adjustments to the bed leveling knobs to try and get the perfect distance between the nozzle and the print bed. I was able to improve the situation a little bit, but ultimately the warped print bed kept me from getting absolutely perfect results. This is a fairly big print bed, so it's not entirely uncommon to have some variation in the print surface, but ultimately what I found was that for future prints, I was going to offset my prints to the front left quadrant of the print bed, where I found the surface to be the best. Later in the video, I'll show you guys how we can install an auto bed leveling sensor to make better use of the entire build platform and get absolutely perfect first layers. Leaving the machine unmodified, I printed a few more objects in PLA to show the printer's capabilities, and this first piece here is this fidget toy. It has some fairly tight tolerances so the two halves can break away from one another, and then the mechanism inside will ratchet. The SP5 had no issues with the tolerance requirements, but I did notice a few more blobs on this print. I switched out the filament to another brand of PLA that I was a little more familiar with. I felt that maybe some of those blobs had to do with the temperature settings for the filament. It seemed like my intuition was correct, because then I printed this Squirtle model here in some blue sparkle PLA, and it came out looking absolutely flawless. Truthfully, I did not expect this printer to perform this well, and that's because of the hot end and extruder. I felt like that was going to be the weak point of this printer. I'm just generally not a big fan of Bowden tube setups, especially machines with this long of a tube, but it looks like it's working just fine. With this beautiful blue filament, at some point I also printed something here in vase mode. In vase mode, the extruder should not perform any retractions, so really what I was testing here was just the uniformity of the walls. It was a slightly taller print, and I was not at all disappointed with how it came out. On this print, I couldn't find a single flaw in any of the features. Now that being said, keep in mind that I did have to print this again in that front left quadrant of the print bed, and that's what enabled me to get that perfect first layer and the rest of the print looking absolutely phenomenal. And on the inside, there was only just one or two tiny little strings that I could remove with my hand. Those first results looked very promising, but as always, there's room for improvement. I wasn't happy with the routing of the Bowden tube. Sometimes it would get caught on the rear corner of the frame. I also wasn't crazy about the strain relief on the X-axis carriage. But first, we'll address that Bowden tube. I designed this Bowden tube guide that attaches to the horizontal frame member using some M4x10 screws and M4 T-nuts. The guide can be slid along the extrusion member until you find that it's perfectly centered on top of your extruder. Then you can tighten those screws, and now your Bowden tube will no longer get caught on that rear corner of the machine. I also designed this mount for an auto bed leveling sensor in the form of a BL Touch, CR Touch, or 3D Touch type model. We'll install one of those sensors later, but I'm showing you the bracket installation now because the strain relief bracket that I also designed fits on top and it'll block access to those mounting holes in the front of the carriage. To mount the strain relief bracket, you'll remove 2 of the M3 screws on top of the carriage. You'll put the bracket on top and then you'll install 2 longer M3 by 10 socket head cap screws, and I've used some washers here to spread out the pressure on top of the plastic printed part. Zip ties will hold the harness and the Bowden tube in place, and that improves the situation on top of that carriage. I also designed this mount for the filament Renault detection sensor. You can see that I've inserted 2 M4 by 10 socketed cap screws with T-nuts on the one side of the bracket, and we're going to be attaching the filament Renault detection sensor to the bracket using M3 socket head cap screws. You're going to need screws at least 20 millimeters long. The bracket attaches to the rear frame member under the extruder motor, and you'll want to position it to leave a small gap between the Renault detection sensor and the extruder. All of these models are free, link in the video description down below. Now we can get the machine set up with an auto bed leveling sensor, and Two Trees sent me this 3D Touch model from their website. I would recommend going with this one because they give you a cable with connectors on the end that are compatible with the main board, and you're going to want to select the 1.7 meter long cable because of the size of this machine. When you first take the 3D Touch out of the box, it has a shorter cable on it, so just remove that and install the longer 1.7 meter long cable, and that connector is keyed so you can't put it in backwards. Find some M3 screws to attach the 3D Touch to the bracket that I showed you earlier. Anything 6 to 8 millimeters long would be appropriate. Now you can remove the 2 access panels on the top of the machine base. The custom one on top of the main board you can find on my printables page with the rest of the upgrades. We're going to be running the 3D Touch cable down through that rear access panel, but to fish it through over to the main board, you may have to remove the bottom cover of your printer. This will make it easier to grab that new cable and route it over to the main board, and keeping it away from those Z-axis belts. At the main board, we can disconnect the Z-axis limit switch, and we'll be replacing this with the green connector from the 3D Touch wiring harness. And if we have a look over by the stepper drivers, you'll see 3 more pins for the BL Touch, and it says ground, 5 volt, and signal, G being ground, and that's going to be our red wire. This is the other connector from the 3D Touch, so we can just simply plug that in. Reinstall the covers, turn the printer on, and check your firmware version. If you have this version or newer, you should be able to do this whole setup through the touchscreen. Now we need to change some values in the machine size settings. In there, we want to change the Z-axis minimum stroke. We need to change this number to -10, and this is going to allow us to move the print bed past Z equals 0 to account for the Z-axis offset of the new probe. We're also going to need to change the print bed size, and here you'll see me type in 290, but I would actually recommend 295, and this should work well with the probing margin that I believe is built into the firmware for the new auto bed leveling sensor. If you leave it at 300, the printer may try and probe beyond the edge of the print bed and you'll get a nozzle crash. In the advanced settings, just make sure under the Z2 settings that your Z2 motor is enabled, but the Z2 end stop is disabled. Then we can head back into the regular machine settings, and the home directions should match my settings here. So the Z-axis home direction should be set to minimum. In the end stop type menu, make sure that the Z-axis minimum end stop is set to open. Then hit the next button and the leveling sensor should be changed to open. Now go back into the machine settings and hit leveling settings. In the leveling settings menu, make sure that enable auto leveling is on, enable BL Touch is on, and the probe connector is set to Z minimum. Now you can hit the next button and you'll see the Y-axis offset, which is the probe offset to the nozzle, is -45 by default in the firmware, which is coincidentally the correct value if you're using my auto bed leveling bracket, so you shouldn't have to change anything in. Now is a good time to start preheating the print bed in preparation for setting the Z offset as well as the auto bed leveling. So I'm going to heat this up to 60 degrees and let the print bed heat soak for a while. Once the print bed is hot, I'm going to home all axes, and this should now use the 3D Touch to home the Z axis. Keep your finger on the power button just in case you did something wrong and that print bed is going to end up crashing into the nozzle. You can quickly turn the machine off. Now I'm going to head into the Move menu, and I'm going to start trying to find the Z offset. So I'm going to jog the print bed up to Z equals 0, 10 millimeter increments at a time. And we're going to now put our piece of paper between the nozzle and the print bed. I'm going to switch over to smaller increments of 1 millimeter, and I'm going to very slowly bring the print bed up even closer. So now we're going into the negative Z domain, and then eventually into 0.1 millimeter increments. And I found that negative 2.8 millimeters is the perfect distance from the nozzle to the print bed. Your Z offset might be slightly different, so don't just enter my value, definitely do this yourself. Now go back into the machine settings and change the Z axis minimum stroke to 0. So we basically switched it back from -10 to 0, and now we can hit auto bed leveling. If you did everything correctly, the probing process should start. However, when I was messing around with this very convoluted process, I happened to screw something up in the firmware, and when I hit auto bed leveling, I was presented with this Z offset screen first. And this shouldn't happen. You should get this screen after the print bed has been probed. And it didn't matter how many times I pressed that button, it would just home the Z axis and then the print head would sit there, and again I would get this screen over and over again. If this happens to you, like it happened to me, you need to go back into the menu and there's a button to reset all of the factory default settings. For me, that fixed whatever I had screwed up when I was trying to figure out this whole process, and then I had to basically start over with all of the steps that I already showed you guys. And again, if you do all the steps in the correct order that I've just showed you, you should actually see the print head probing the bed, and then after the probing, you get the Z offset screen. At this screen here, this is where we're going to enter in the Z offset that we found earlier of -2.8. And the reason we did it earlier and not now is that as I'm pressing these buttons, the print bed is not actually moving. And so you can't actually measure it at that step, you just have to already know it and enter it. So again, that's why we did that first. With the Z offset now entered, we're going to home the printer and we're going to double check the Z equals 0 position. So the print bed will get parked some safe distance away, and in this case it's showing us 22.8 millimeters. And in my case, after that whole procedure, when I try and jog the Z axis, the printer was unresponsive. So I power cycled the machine, and this time it let me move to Z equals 0. And when I checked with my piece of paper between the nozzle and the print bed, everything checked out and we were actually at Z equals 0. We're very close to testing out the auto bed leveling, but in your slicer, one thing that you should add is after the last call to G28 in the start G code, you should add M420S1. This is going to make sure the last saved mesh is loaded up before the print starts. And if you guys use Prusa Slicer like I do, I'll put a link in the video description to my slicer profile. I'm reprinting this first layer test that I showed earlier in the video, and this time it prints perfectly despite the print bed being slightly warped with that high center. And while the print is going on, if you look very closely at the Z couplers, you'll see them moving back and forth, making adjustments to the Z axis while the print is happening. I was very happy I was able to do this entire setup from the touchscreen. However, as you guys can see, it's not the most intuitive process. Now we can have a look at another print. This time it's going to be a Spider-Man bust. And you can see that with the auto bed leveling, I was able to print right in the middle of the print bed, which previously would have been slightly too high, as I was sort of offsetting my prints to the front left quadrant of the printer. And this print came out looking very nice. And I just printed this with some off-brand red generic PLA, but you can barely see the layer lines. This was done at a 0.2 millimeter layer height, and I would have to think that this level of smoothness in the print is attributed to the machine having linear rails on all axes. The only minor flaw in the print was under Spider-Man's chin, and this is a pretty severe overhang on the print, so perhaps the part cooling on this machine could be improved just a little bit. But other than that, again, the details were very crisp, and overall my expectations were exceeded for a machine that is basically unmodified. I've got one more upgrade for you guys that I would highly recommend, and it's a PEI coated flex plate. You can find these flex plates on my website, embracemaking.com. To install the flex plate, the first step is to thoroughly clean your aluminum heated bed. I'm using some isopropyl alcohol to do this. The next step is to take the included magnetic sheet. One of the sides has an adhesive layer. Peel back a small portion of that adhesive layer and then get the rest of the sheet lined up with the aluminum plate without sticking anything down just yet. Once you have it perfectly positioned, you can take a soft cloth or some paper towels and press down on the center of the portion of the magnetic sheet that has the exposed adhesive layer and work your way from the inside out. Continue to slowly peel away the peel ply layer, and again, use your soft cloth or paper towel to push down on the center of the bed and work your way towards the outside so you don't get any air bubbles trapped. Eventually you'll get right to the end, and if you did everything right, it should look like this with no air bubbles, and you can snap your PEI plate on top. We'll print something on top of this flex plate, and we're going to be using this white PLA that Two Trees sent me. You can find this on their website. The advantage of using a PEI flex plate is the superior adhesion while the build plate is hot. But when your print is done, you can peel off the build plate, give it a gentle bend, and your print will pop right off. If you imagine that you had adhered the glass plate to the aluminum heated bed, then every time a print finishes, you would have to wait a very long time for the glass plate to cool down before you could remove your print. Another thing to keep in mind is that my flex plates are double-sided. The other side is textured, which leaves a pretty cool finish on the first layer of your print. Overall, I felt like this printer is very good value at this price point, and it has a ton of potential. But I would recommend it to people who are more into tinkering and upgrading their printers, because somebody who's new to 3D printing might find the initial setup a little bit frustrating. The instructions could be more clear, and I found it odd that I had to adjust things like the machine limits in the setup, and other small details could have been improved, like having a filament runout detection sensor mount included with the printer. That being said, once you get it up and running and calibrated, it does perform very well. You guys saw that I did get some really nice prints off this machine, which did surprise me considering the exceptionally long Bowden tube and the generic hot end. The only other problem was, at first, I wasn't able to make use of the entire print bed because of the lack of auto bed leveling sensor and the slightly warped build plate. And so if you guys are gonna do any upgrade on this machine, I would recommend spending the extra $18 on the Two Trees website and getting the 3D Touch included with your kit. I personally had to spend a lot of time figuring out how to get it installed, but of course I showed you guys how to do that in the video. I went through a lot of trial and error in hopes of saving you guys a lot of time and headaches. In summary, I think you're getting a lot of hardware value with the SP5, and what you're looking at is a very solid Core XY machine to get started with a few small simple upgrades like perhaps a higher flow hot end and a direct drive extruder. Pairing that with Klipper, I think what you'll have is a very capable high-speed Core XY machine. And you know that video is coming, so hit that subscribe button so you don't miss it. So thanks again to Two Trees for generously sending me this printer. Be sure to check them out, check out their website. Also check the video description down below where you'll find all of the relevant links to all of the upgrades and various things that I've mentioned in this video. And be sure to visit my website, embracemaking.com. If you'd like to support me and my work, your support goes a long way in helping to fund all of these videos and all the time that I put into them. Thanks for watching.